I should point out that we will be recording this afternoon's session. In fact, the recording is in progress. You just need to click that you wish to proceed. We don't want to lose you before we start. So, welcome to our guests, our presenters, friends and colleagues, visitors and anyone else who's made the excellent decision to spend the next 2 hours with us. So welcome everyone to the Wednesday session of the Central Event of European Robotics Week 2021. I can also say for some of you, welcome back. We had a fine start to the Central Event on Monday. If you were unable to join us live for that session, you'll be able to see it when we release the recording, which will be soon. So this afternoon, we are back once again in Bologna, as you can see behind me, a historic city, capital of Emilia-Romagna region of northern Italy. We learnt on Monday that Bologna is known as the fat, the red and the learned city. Fat because of the richness of the food, red because of the roof tiles, and learned because of its university, which can claim to be the oldest university in the Western world. And I know that some of our guests and colleagues today are in physical Bologna. Many of you are elsewhere in Italy and indeed elsewhere in Europe. It doesn't matter where we are, though, for the moment. For the next 2 hours, in our hearts, we can all be in Italy, and through our minds and our eyes, we are all in virtual Bologna. My name is Steve Doswell, and on behalf of EU Robotics, I will introduce our guests and keep this event moving for the next 2 hours. Okay, so we ended Monday's opening session with a summary of this year's Xerox competition, and today we begin again on the theme of robot competitions, and this time the focus is on the winning teams of Italy's National Robotic competition with its compelling and relevant title, Water, Earth, Air, Robot Save the Planet. So at this point, I think I will simply hand over to Emanuele Micheli from the Scuola di Robotica. So, Emanuele.
Thank you very much, Steve. Thank you to the European Robotics Week to open with us and our teams from this very important national event about robotics for school, for secondary level of school. So we are very happy and proud about your invitation. So thank you very much for this. And we are very happy to see our teams, our three different winners about this project. 2 words about Scuola di Robotica and about this project. I am Emanuele, I am the president of this no-profit society that is working in Italy, in Europe, and all over the world to introduce robotics as an educational tool, to introduce robotics as a tool for future for our students from kindergarten to university and after school and during the professional life of everybody. In this process, we are proud that our Ministry of Education in the last 3 years asked us to organize a very important event for our nation, for our country, and for our Ministry of Education. This robotics event is called Olympiad Robotics Game for Italian teams that involve more than 100 teams, 100 schools from all the Italian territory. And for every year, we choose different teams, different topics for our teams, and we follow them in an educational process with their teachers. I want to say thank you to all the teachers, professors that follow their teams, their students in this adventure, because I know without teachers it's not possible to change the world. And I think that I'm very happy to see some professors that I know in different way, but I know that they are engaged with students. So thank you very much, professors, to be here with us. And we are very happy because the last edition that during the pandemic, during the lockdown, we lead online, but the project of our students, of our schools, are a real project to save the planet. And I cannot see, I saw during the event all the enthusiasm of our students about these different projects. So three different categories: water, land, and air, and three different winners. So I want to give the word. I didn't decide an order. Okay, there is not an order for importance, but the Zoom order. So the first team that I ask to speak is Daphne team from Marche. So I give you the word. Thank you very much. I want ask you to present your projects.
Hi everybody, we are from IESI, as we already know, and we are in our mechatronics lab, where there are stored all our projects, and near me, at my back, there is the Daphne boat, as you can see. And we prepared also a little PowerPoint and to explain better this project. Can I share the screen?
Yes, I ask to Steve or the other organizer to give you the permission to share the screen.
Yes, I think Reinhardt has the controls on that and can give you permission.
Yes, okay, let me just see. I need to find him. 1 second, please.
No problem.
So you should now be a co-host.
Nice. Yeah. We can see, guys.
This is the Daphne boat, and we created this boat in order to recover plastic waste from seas and lakes. And here we can store the plastic bottles. For example, we collect plastic bottles from lakes, seas, from the surface of water. And we made this process. Yes, we created all the designs at our school, in our laboratories, and we used CAD and CAM software, and we manufactured this project in our school. And Daphne, we tested Daphne. We tested Daphne in a pond near our school, and we see in a little lake near our school, and
Studenti non capiscono niente.
sorry.
Okay. I don't know. That is.
Yeah, just a message to everyone. If you are not presenting, could you leave your microphone on mute, please, so that the presenters can speak. That's fantastic. Thank you very much.
The test, we test how the boat was floating, and it can collect properly bottles and other plastic waste in a pond near our school, as I already said. And the Daphne boat, yes, the Daphne boat is equipped with a micro camera, and we can use the technology of augmented reality to collect plastic waste. and
Control.
yes, and we can use the remote control to move our boat because it has been equipped with a proportionally controlled remote control, and
You can see what the boat at the front. You can see, and with the camera, we can look where is in front of the boat, and so we can change the direction, and we can see the boat almost 1 kilometer from us, and try to check everything the boat have in front. Yeah.
And as we already said, we got the excellent results, thanks also to the remote control headset, because it makes a lot easier to control the boat.
Exactly.
And yes, and that's it. That's all from our mechatronics lab, and I hope you enjoy the presentation of our project. Thank you.
Thank you guys for your presentation, and that is very interesting projects about plastic in the ocean. So that is a very hot topic for our world, and I think that is a topic that we need to be aware about the problem of plastic in the ocean, and that is very interesting that you can demonstrate that robotics can be a solution. So thank you very much. I ask you to spend 2 minutes about your schools. What is your schools? I don't know if Professor Fattorini want to speak, or students, because it's interesting to understand the background of schools that lead this project.
Okay, our school is a high school and is a technical school. We are now in a mechatronic lab. Usually here we made a project. We made different projects, and every year usually we do 2 or 3 projects with a different classroom. And we try to use and know very well Inventor Studio and Virtual Design 3D, and use some CAD/CAM system because we need to organize stuff and produce stuff of ourselves. And sometimes we try to make a good programming with PLC, because some projects need the system HMI for its control. So more or less, I try to explain what we do every year. Sometimes we do well, sometimes maybe less, but every year we try to do the best.
Thank you, Giuliano. That is
You're
very
welcome.
interesting to understand that your school is on the edge about robotics and about the educational process with robotics in your educational activities. So thank you, and I hope to find you in the new Olympiad robotics game, because is an important news. The Ministry of Education asked us to organize the new edition, and we hope that this new edition will be in presence, because after 2 years of digital version of Olympiad robotics, we are not very happy, because we want to touch in the real world your projects, and I want to see you in our next edition. So thank you, Giuliano, and thank you all the team for your efforts about that. Stay tuned, because I don't know, but we can have 5-minute session of question and answers from the other persons. So I ask you to stay with us. Other team that I know they are participating in Robotics Olympiad for a lot of years in the last 4 years, I think so, is Liceo Scacchi in Bari, in South Italy. And I'm very happy to see the professors, Manuel and his team. So I give you the words. Can you introduce your project? And the stage is yours, guys. So Liceo Scacchi from Bari.
Hi everyone. Good evening.
So some moment to manage the situation. And are you ready?
Yeah,
okay.
we're ready.
Let's go.
Good evening, everyone. We are Arachne team of the Scientific Art School Arcangelo Scacchi in Bari. Our robotic prototype was born with the aim of creating an eco-sustainable agricultural model because it analyzes the tree plants in their individuality and the soil in its specificities that varies from area to area. And in this way, we can ration of fertilizers and water for irrigation. It is essential in our age, characterized by an exponential decrease on natural resources. But Arachne also identifies and eliminates the weeds of the field that would otherwise steal important nutrients from the crops and would hinder their growth by paralyzing heat. So we have chosen the agronomic weeding, which implies the use of mulching, and this latter allows carbon sequestration to take place. Carbon sequestration is a fundamental process for a planet like the Earth, which is overheating due to the excess of CO2 in the atmosphere. Knowing the electrical conductivity is used to plan the methods and times of fertigation. Humidity and temperature, on the other hand, are fundamental indicators for managing irrigation distribution. The cation exchange capacity is the variable that expresses the chemical fertility of the soil. Regularly monitoring the pH and NPK of the soil and checking that it has not gone out of the optimal range serves to ensure optimal growth of the plants and to avoid the risk of certain disease. The pH and NPK impact influences the solubility of nutrients within the circulating solution.
During the displacement, Arachne carries out the geolocalized mapping of the field. Thanks to it, site-specific management of the soil can be implemented or targeted, and optimal decisions linked to fertilization, irrigation, and types of processing. We have introduced new types of sensors, like infrared motion sensors, which allow the robot to stop moving near bodies that impacts with the elements on its trajectory as wild animals that could damage the air. We also used UV radiation sensors, which allow to control the status of the soil. Thanks to this type of sensors, the consequences of an excessive UV exposure could be of some trees, such as burned foliage, cessation of sprouting of native species, or even miniaturization of some bodies that still grows. Barometer, thermometer, and hygrometer, as far as the barometer is concerned, are necessary to have a more complete general picture of the environment in which the robot will work by identifying the air values that differently influences the various layers of the ground.
So this is the environmental aim of our robots, and now we leave the stage to engineers of our robot.
So we leave the stage to Paolo Ginapra from Milan. Hi, Paolo.
Hi, everyone.
Hi, Paolo.
Because I'm no longer in high school.
Paolo, the audio is not so good. You can...
Do you do better?
Yeah, so and so. Yeah, I know that you have to wear the mask because it's important. Yeah. You are not in an individual room, so it's important. Speak louder than than before. Thank you.
If you don't hear me at any moment, please interrupt me. So I was saying, I'm about to talk about the movement system of our robots, and when we were designing Arachne, we knew that it would need to be able to move on quite an uneven or fragile terrain, so like the cultivated field. So movement had to be a really important part of our robot. We knew that we needed to give the robot the possibility to move quite freely on the terrain. So we opted for leg robotics, inspired by the animal world, because it could achieve 6 degrees of freedom, so like the 3 degrees of translation and also the 3 degrees of rotation. Then we tried to decide the optimal number of legs for our robot, and we opted for 6 in order to give spatial stability with just a legs on the ground. In this way, we could use 3 of the other legs to do some tasks with some effectors at the tip of every leg. In order to achieve the movement, we also designed some algorithms. In particular, we used some inverse kinematics and some interpolation in order to achieve this movement at the scale and the control of the robot. I think that's it for start. This page to Alice.
Yeah. We can see the robots moving.
Yeah, the robot is here at Bari. So you can see it moving in the second cam from Giuseppe Scannapieco. And now, Alicia, let's go.
Okay.
So thank you, Paolo. I don't know, Manuel and your team, if you want to add more about the robots and about the Olympiad Robotics game. Okay, I saw that you are moving the camera and we can see your beautiful robot. So I don't know, Manuel, have you, okay, you are sharing something that is not possible to see for us. I ask you some things because Manuel, we cannot understand what happened. Can you hear me? Manuel, we cannot hear you. You cannot hear you. Manuel, there's a problem.
I think you need to unmute yourself. I think you're still muted.
Yeah. I ask you to unmute. Manuel Licioskaki, unmute your audio. You are on mute. You are on mute. I don't know. Okay, we can wait some seconds to understand how to solve the problem because Manuel and his classmate are totally frozen. So you can see that is a very interesting information. All the videos from these teams and the other 30 teams that, okay, we can hear you, Manuel and co.
Okay, now.
Okay. Sorry. No problem. Manuel, I give you the words. Yeah. And I ask, I don't know who is the manager of the call to put in principal video Licioskaki because probably they have some things. Or I ask Manuel to share the video because for us it's not possible to see very well. So you can share some things or not, Manuel?
Wait a second. Can you hear me now?
Yes.
Okay, perfect.
Step by step.
Okay,
Second step, can you share the video?
Sharing.
Is okay. I ask the manager of the call, Reinhard.
Yes.
I don't have a
Yes.
video,
My screen.
but you can share your screen yourself normally.
Yeah.
Yeah, but it's so small. So
There isn't a problem. So.
But if they were to maximize the screen for screen share,
Yes.
that might be better.
I did it. I did it.
Just a graph, so it's important. So welcome everyone. I'm Manuel, and I managed the sensor part of this prototype. So the collecting, the sharing, and the publishing of the data. And at the base of this prototype, we can find three robust sensor and decay sensor. Thanks to this sensor, we can monitor the nitrogen, potassium, phosphorus, pH, cationic exchange, and temperature and the humidity of the soil, the cultivated soil. So we can applicate a site-specific gestion of the camp. Using the Arduino MKR, that I don't know this. Using this Arduino given by the School of Robotics of Genova, we could implement several sensors like UV sensor, barometer, hygrometer, and ambient thermometer. So we monitor the condition above the soil too, and with the help of the movement sensor, we can identify any animal near the robot, and we can activate the PP cam under the robot to track it. And after this, buzzer is activated, and frequency sound are issued by this buzzer to scare the animal. And at planned, thanks to the Wi-Fi sensor of the Wi-Fi communication of the MKR 1010, we could implement a database developed in a Mongo database thanks to the platform Atlas. And these data are accessible from everyone using a free website developed with Heroku and Dash Python library. So the website is accessible at this link, mksensorchu.herokuapp.com, and you can see some heat map, and it's organized by this date and some graphs. And there is also a local visualization of this data, and it is using matplotlib and Python. So let's start. And as you can see, sorry, but we haven't the soil.
But we can understand, Manuel. It's understandable.
We forgot it, and we can see the graphs developed in matplotlib with Python, and if I touch the sensor, there is a little bit of rising up.
Okay, no problem. I am also the time man, so I probably I don't know if you want to add more, but 1 minute, no more.
Yeah, just a little bit.
Okay, so at the end we have the artificial intelligence part that is based on a photographic approach. It means that Arachne combines both algorithmic and machine learning approach. And with the algorithmic approach, we can get the average color of plants, so we can get various like the chlorophyll one. And with the machine learning approach, we can understand the species of the plants and the well-being score. And so from these values, we can get plants as pathologies and much more. So for reading, that is the final part of the Arachne, a camera is used, and
that is combined with machine learning approaches, and from those approaches we can get the position and the area in which there are the specific area in which there are plants and weeds. So when the machine and so Arakan gets and understand that in a specific points there are with are activated the two rotating blades, and for example here we have a plant image, and if we put it in front of them so as you can see, if we put in front of the camera the image of a plant, the rotating blade is activated. So with the two central leg of the robot, those two blades are activated, and that's it.
Thank you. Thank you very much for your nice presentation.
Thank you for giving us the time.
Thank you. You are welcome. So the last but not the least, because there are another team that can present their job, their projects, that is Vol team. I asked them to activate your audio. Thank you, Arachne team and Vol team, welcome. So I give you the stage.
Good afternoon. We're happy to be here at the Robotics Olympiads. I would like to share my screen.
Okay, I ask it
should be possible. I made you already co-host. So, and the team from Bari, please switch off your camera so that the others are visible. Thanks.
1 second.
Okay. Fai schermo intero.
Is there any question?
Can you see our presentation?
We can see your screen probably, and now we can see Gasco, the project.
Yes, thank you very much, Dan.
Let's go.
Okay.
Yes. We are a small group of students from the technical school Alessandro Volta in Borgonovo Valtidone, a tiny village in Emilia-Romagna. We come from different places, but we all share one passion, robotics. Our coach is Professor Angelo Maggi. He teaches mechanics in our mechanics and mechatronic course. Our school has always fostered curricular and extracurricular activities which require the use of labs, robotics, and digital technologies. Students are enthusiastic about them, and many of them decide to join our team every year. During the development of the project, we had to deal with many difficulties related to the global pandemic. We learned how to communicate and share ideas online using different platforms provided by our school. To create our prototype, we used our school labs, which in recent years have been expanded and updated. We must admit it, and they are our pride and joy. The project, Gasco. We started our creative process with multiple brainstorming sessions. We decided to work mainly online to ensure everyone's safety during the pandemic. After reading some newspapers, we soon realized that in our area, a substantial number of work accidents had occurred. On different occasions, they were caused by the presence of poison gases in tanks. We titled our prototype Gasco, because casco is the Italian word of helmet. Safety helmets were part of the PPE, personal protective equipment, often used on construction sites. Our idea was presented to multiple winery owners in our area and to representatives of factories that deal with products that can produce flammable gases. People responsible for the safety of workers have shown interest to encourage us to carry on with our work. Our team had the idea to add 3 sensors to a normal safety helmet. This sensor needed to produce a signal in order to inform the worker that dangerous gases were present. An acoustic signal and 3 LED lights signal the 3 levels of danger. They indicate the presence of carbon monoxide, flammable gas, and fumes. We inserted the sensor and the LED lights in 3 different colors inside a plastic support that we created in our school labs. We used Inventor to design it and our 3D swap to print it. We assembled it and applied it to an average safety helmet. Our goal is to be able to provide a product which can be applied to existing PPE so that it can be personalized according to different needs. The system was through Arduino Nano and through a simple software which was fully created by students. The cost we needed to face to produce our prototype was not high. The helmet and electronic components are quite cheap. Luckily, our school already owned the necessary equipment, which would have been otherwise quite expensive. Our multimedia classroom, our ACT and CAD labs have allowed us to design and produce our prototype. Software.
Thank you.
Today, some of the team members can't be present because they graduated last year and they are no university students, most of them choosing engineering. To represent them, we have... Hi, my name is Amin, and I graduated last year from the school. Now I'm here today to participate in this event.
Speak louder, guys.
Hi, my name is Amin, and I graduated last year, and today I'm here to participate in this event.
Thank you.
I'm Michele, and I'm a student of Politecnico Milano here in Piacenza, and thank you for this.
Thank you.
Hi, I'm Younes, and same. I study at Politecnico di Milano, mechanical engineering.
Okay. Thank you very much for your attention.
Thank you. And
do you have any further questions?
I don't know. From my side, can you hear me? From my side, I want to say thank you to everybody. And I give the word to the organizer of this Zoom session about the European Robotics Week, because I know that we use all the time that they give us for this nice presentation of the 3 winners of Olympiad Robotics Game. So thank you very much. All the 3 projects are beautiful projects, and how to the last team explain us this context of robotics are very important as orienteering for our students for their future. So it's very nice to understand that they are working on robotics in school, but after that they are very happy to follow their passion, and their passion is robots, that we are very happy about that. So I give the word to Steve and Rainer, and thank you for the space that you give us for this moment.
Thank you, Emanuele, and thank you very much to the 3 teams, to Team Daphne, to Arachne and Volt team. I think what we've seen there are 3 very valuable solutions to 3 real world problems. So I congratulate those teams for their solutions, but also for their communication skills as well, and not least to present all of that in English. A director once said to me, it's not enough just to have ideas, you need to be able to communicate those ideas, and I think we've seen that from our 3 teams here that they really understand that, and they've made a real effort to communicate each in their own particular way. So thank you very much. Okay, so and not least Emanuele, I think you managed that session in a live and potentially volatile environment. So so well done to you too. Thank you.
Thank you.
Okay, so we are going to move on now, and our next theme in the middle of our session today is the theme of autonomous aerial vehicles, UAVs or UAMs, more commonly known as drones. You will hear about this from 2 perspectives. Firstly, will drones become part of our future daily life? And we're delighted that Antidio Viguria, a member of our e-robotics board of directors, is here to address that question. And in the second perspective, UAM challenges and opportunities, we're equally delighted to have Giuseppe Scannapieco with us. I'm going to introduce Giuseppe first, but then go on to Antidio, who'll be the first person to speak. I hope that makes sense. It makes sense to me. So Giuseppe Scannapieco is a drones project manager at EASA, the European Union framework for drones. Giuseppe has been with EASA for 10 years and has had extensive experience of complex aircraft certification. Giuseppe's move to EASA in 2011 followed 7 years with Aeronautica Militare, Italy's Air Force, where his involvement with flight test management, experimental aircraft configuration management, and helicopter performance provided an excellent grounding for his present role. As always, given the high quality of our speakers, there is much more that can be said, but we must move on. We will hear from Giuseppe in a while, but first, let me introduce the person you will hear from first. So Antidio Viguria Jimenez, Chief Technology Officer for Avionics and Systems at CATEC, the Advanced Center for Aerospace Technologies, based in Seville, Spain. Antidio has been at investigator of more than 50 research projects related to unmanned aircraft systems, aerial robots, and the application of technologies to aircraft manufacturing processes. So please welcome Antidio.
Thank you. Thank you very much, Steve, for inviting to this. I would like to bring an introduction to what is expected to us. The challenges are also very nice application that we expect to see in our daily life and in our cities in the next 10 years. So let me just share my screen. Okay. Okay. So, well, I don't know if everybody in the audience is already aware, but drones are here to stay and they will have an impact in our lives in the next years for sure. There are, in the last, I would say, 3-4 years, there have been a lot of development and research about what we call advanced aerial mobility service that will really change our lives. There are, I would say, 2 main applications that it will impact our daily lives for sure, and there will be others, but as a first perspective, we can see of two main applications. One you can see a little bit futuristic, but it's also more closer than you can expect, which is aerial taxis or aerial mobility, transportation of people by the air. So you will be able to go from the airport to downtown by an aerial taxi without all the traffic jams. or you will be able to have a touristic, flight around a sightseeing place in your city or in another location in Europe using an aerial taxi. So we will talk a little bit about later, but this is actually coming to stay. Then another type of application that also has a lot of impact, and because of, for example, all the news related to Amazon and things like that, it also has been widely covered by the society, is logistic or transportation of different type of items. So instead of ordering something by your favorite application, and instead of coming by regular mail or by a car, it will come very fastly by a drone. Okay, it doesn't, probably it's not going to land on your garden, but as you can see in the picture, probably it's going to deploy. You have some kind of mechanism, so you are able to get your whatever, something that you need urgently, or something that, for example, maybe I remember one presentation of one of the companies. They say that there were a lot of people during the pandemic, because they're having some pilots, they started to ask books, books or something like that. So, for example, the people that work in the houses, in order to fix stuff, instead of going to the store to buy a specific tool, they ordered by the drone, and it saves a lot of time. So all this new technology will have impact, but it has also an objective to make our life easier. It will save probably a lot of time, of transportation. All these vehicles have electric, so it will also help to decrease the pollution and help to fulfill all the major objectives in terms of environmental that we would like to achieve in Europe. And in general, we improve the citizen of our lives, not only in urban areas, also in the rural areas that are a little bit isolated. We think that this kind of vehicle can also help a lot to get able to some kind of services that right now are only available in the cities. Okay, so going to the different type of applications, the aerial taxis, you can imagine, is this a reality? Is something that is already happening? Yes, you can see here 5 pictures of 5 prototypes that and most of them are already flying, or in demonstration or in experimental flights. But they are actually companies that they are working right now that are fabricating this type of aerial taxis. And you can see that the configurations are very different. Usually these kind of vehicles, they require to be what we call VTOL, so which means that you don't need a runway to take off and land. So they can take off and land from smallest places that we call them vertiports. Okay, so we will have vertiports around the city, and they will be able to pick up people and go to one place to another inside the city. So this is something that is already happening. Actually, in Europe, I would say there are three main companies working on that. Of course, Airbus, which is the one on the top left. They have just presented the new generation of what they call the City Airbus. And also they will have also, for example, a couple of German companies like Lilium and Volocopter that are also quite advanced. And of course, we are not only ones in Europe, also in the States and in China, there are companies working on that. Regarding the logistics, well, here also has been some interesting pilots. For example, in this summer in Spain, there has been a company that they have started to deliver a service called Drone to Yacht. So the people on the yacht were able to ask for food or for any other thing, and it was delivered by a drone. Okay, it was actually operational this summer in Spain, in Ibiza, for example. And there are also a company, for example, called Maternet, that they have been doing some pilots, some demonstrations in Switzerland, in Zurich, and also in Berlin, and also in the Emirates. As you can see in the bottom right, there are also some, you not only need the drone, which is this aerial vehicle, which usually has some kind of device to transport the whatever it has to be transported, but also the companies are thinking about this kind of stations, so you have this kind of station, as you can see in the bottom right. that they will land on that, and then it will be a robotic mechanism that will take what is being transported, and then with identification you are able to grasp it. So it's some kind of delivery station, but especially designed that a drone can land, and then there's automatization mechanism that allows to take the load and store it until the user asks for it. Okay, and then also we have in the bottom left, this is the UAV from Wing, which is a company from Alphabet, the Google main company. And they have started different pilots all over the world. They have a pilot in the United States, they have a pilot in Australia, and also one in Finland. So they have been able right now, I don't know, but for sure more than 1,000 deliveries, successful deliveries, or even more. So there are some, as yet there are some right now, some successful pilots, okay? So companies are starting to provide services, not I would say to everybody, but for some specific locations. And we hope that in the future, in the near future, this will be extended to much more locations. So this is very, very interesting. Also, there are people, for example, a company called Seedline in Africa that also they are delivering medical devices and medical components to rural areas. So there's a lot moving on. It's something that is really happening. It's not something like the movies. It's something that already there have been some experience. So all this experience, we have great challenges, in order to make this a reality. For example, the endurance of the battery, the noise, especially for the aerial taxis, for the big ones. I don't think we want to have a lot of noise in our streets based of these taxis. And then also we have two main challenges. We have to integrate these vehicles into the airspace. The airspace is changing. Now there will be much more actors, not only the general aviation or the commercial aircraft. It will also have drones. We will have aerial taxis. We have other kind of vehicles, and we have to integrate that into the space. And also we have to integrate them safe. Okay, it's important, for sure. Giuseppe later will comment that without safety, there's no business. So safety is first, okay, in aviation, and drones is part of the aviation. And here we think that robotics can help in all these applications, in the aerial taxi, in the logistics, for the integration of the space. We need, for all these business cases, this aerial vehicle, they have to be really high autonomy, with a high degree of autonomy. So they will need to be able to interact with the environment and react to unexpected situations. And in that sense, robotic technology can help a lot. And instead of UAVs, we'll have aerial robots, aerial robotic taxis, aerial robotic logistic systems. So this is why this is the connection with robotics. So in order to illustrate a little bit this, just showing a video from CESAR. CESAR is an organization depending of the European Commission, just illustrating what it is expected. No, so we have here a drone delivering a medical component to a hospital, and right now at the beginning everything is very easy. But as you can see here, I will go a little bit lower, and you can see here we have a crane in front of it that it was not expected. So it has to detect the crane. Oh, sorry, it has to detect the crane and avoid it. And for that we need autonomy. We need robotics. Okay. So there will be some, for sure, unexpected situation. You can see now that there will be a flock of birds, and also the drones that you need to also to cooperate with them to detect them and be able to change automatically your flight plan in order to avoid them. Or here we have a helicopter, so they will close part of the airspace, and you need again to interact with the system and be able to replan all your trajectories. So all this replanning, all this interaction with the environment require functionalities, services that are taking technology from robotics. Okay, and of course, it's not only delivery, it's also aerial taxi. So all these type of vehicles will require robotic from technology, and this is something that we expect that robotics can support the development of the solution. So, and you can say, is this just a futuristic dream? What we have seen? We have seen some pictures of some platforms. We have seen some video, but this everything was synthetic. Is this a reality? Well, I can show you, for example, this is a flight that we perform in Benidorm. Benidorm is a city in Spain. To this city, you can see it has very tall buildings. The skyline is very similar to any city in Europe. We have been able to perform some experimental flight, but still some flights, as you can see, in a real city with a real drone performing or emulating some kind of services. So this is something that is coming, that there are challenges. For example, the positioning system of the drone in this urban area, where the GPS sometimes is not so good. So you need to fuse, to complement this GPS with other kind of positioning sensors. But apart from that, as you can see, this is something that is already a reality. And this is actually, these flights were performed as experimental flights within the recent European drone regulation that next Giuseppe probably is going to comment. So as you can see, so it's something that that is already happening, and we are flying. Also, this is an indoor application, but it's also it could be very interesting to show. This is a real application that we developed for Airbus. So here is a logistic drone for inside a factory. So the idea here is that the operator, sometimes they require something that was unexpected. For example, they require a resin that has to be refrigerated and it cannot be close to him. Instead of the operator to stop working and going to the middle of the factory, to the other part of the factory to get the resin, it can just order it through the app, and inside the factory, the drone automatically, you just load the drone and then will deliver the component to the operator. And during that transportation, he can continue working and not waste his time and increase the efficiency of the manufacturing processes. This drone is fully autonomous, is able to localize itself without GPS, able to detect obstacles, and is able to position and be able to deliver with a high precision. We constructed this kind of device in order to simplify the delivery operation, and we didn't have to land the UAV on the floor. So it was more safe, because this was a real manufacturing plant of Airbus with the real operator. So as you say, safety was first. And then just to give you an idea what is happening in Europe, this is a video also from Cesar showing the results of a set of research and demonstration projects that they were developed from, I would say, 2018 to 2020, in the last 2 years, just before the pandemic. So this is more or less state of the art. Now they are running another set of projects, but it were a bunch, more than 10 projects that were running in parallel, trying to move forward into this concept of integrating the drones, integrating the UAVs, the aerial robots into the airspace, and to get experience into that. As you can see here, in real operational environments with real demonstrations in real places. And it was a set of projects all over Europe. So there was not only in one country. I think that, I don't know, maybe more than 10 different countries, they hosted different kind of operations. And it was very interesting. And also, if you want to have more information, you can look to what is called U-Space in Google and Cesar, and you can get more information about the drones. And for example, operation from the airports as well, which is also very interesting. So this is something that is already happening, and even with the aerial taxis, okay, operation with the aerial taxis. And then just to conclude my presentation, just to say that there are other kind of applications that also could be interesting for the UAVs. For example, the inspection of infrastructure. Here you can see a video of inspecting a bridge automatically with a drone, and this can also save a lot of time because the operator doesn't have to work at height, and also much safer. So the operator doesn't have to go there up maybe 20, 30, 40 meters, and the drone can perform the inspection automatically. This also can happen to any kind of infrastructure, gas and oil or whatever. So if you have to perform a visual inspection, it's much easier to do it with a drone than with a person going to that specific place, especially when it is working at height. And inspection is not only inspection visually. We are also being in the last year related with aerial robotics. They have been developed in Europe the first worldwide aerial manipulators. So this is a technology that allows a robot, aerial robot, as you can see there, to manipulate from the air, not only to take images, to interact with the environment. Okay, at the beginning was in the lab, and later, this is something that also we did in Europe for applying to inspection with contact inspection, not only visual inspection, but also contact inspection, because for certain inspection, you need to touch. And this, I will say that we are in Europe, we are worldwide leaders in this. In applying aerial robotics in inspection and maintenance, we are right now worldwide leaders thanks to the support of the European Commissions and also all the Horizon 2020 projects that is fostering the research and development. And also now we are transferring this to the industry. And just to conclude, other kind of application could be, for example, monitoring, environmental monitoring with other kind of UAVs or other kind of drones. For example, this type of fixed wing or aircraft, more conventional aircraft type of UAV. And with that, you can cover longer distances and you can monitor natural parks, you can monitor borders and things like that. So this is coming to my end. I think more or less I stayed on the time. I hope it was interesting. And thank you very much for your attention.
Well, that was excellent. That was mesmerizing. Some of the footage of what's coming soon. That's amazing. Thank you very much, Antidio. So I'm going to hand straight on then to Giuseppe to give us a second perspective on drones. So over to you, Giuseppe.
Yes, good afternoon. Well, I would say good evening, and everybody. Thanks for the invitation, first of all, and thanks for the interesting presentation. The one performed now by Antidio was extremely catching up, and I think it links nicely with the presentation that I'm going to deliver. And also, I would like to congratulate all the students because I was really impressed by the works and the activities that they are doing at the school. Please continue to do so and keep studying and be curious. That's the most important part. Now, let's come to our presentation. I will try to share my screen. Let's see if it works, because sometimes. Okay, can you see the screen now?
Yes, we can see it.
Perfect. Now I will try to start the presentation in presentation mode. Okay, I will try to link as much as possible to what Antidio has just said, because I think he pointed at several interesting elements of discussions or reflection, at least, that nicely match up with what I'm going to present to you. First of all, a few words on the agency, because maybe not everybody may know what is what is a European Aviation Safety Agency, what we are doing, and why we do exist. So basically, this is an agency that is established, that is a technical agency established by the European Commission, and we are the delegation to prepare the rules, all applicable rules that will be one day used in the aviation domain. So basically, we care about everything that is dealing with aviation, not only aircraft, but also all the organizations that are around the aviation. So those that design the aircraft, that produce the aircraft, that maintain the aircraft, the organization that are providing training to pilots, air traffic controllers. So everything that you may think associated to aviation is somehow of interest to our agency. We are based in Cologne, here in Germany, and we represent the interests of 31 countries, so the 27 EU member states plus the four additional states, Switzerland, Norway, Iceland, and Liechtenstein. And basically, our main mission is to ensure that aviation in Europe is safe and green. So we have also caring about to ensure an adequate level of environmental protection in terms of noise, for instance, and emissions of aircraft. So as I said before, we are the ones proposing the regulations, and then the Parliament will have to discuss and approve, and try to ensure as much as possible a single level, internal aviation market in Europe, and a level playing field amongst all applicants, all members of the industry. And of course, we are here to promote the European standards, not only in Europe, but also worldwide when dealing with other organizations. As I said before, you may think of us as dealing with everything that has to deal with aviation. When we're talking about airworthiness, so basically it's the safety of the design of an aircraft, the operations and the licensing of pilots, so how to operate, how aircraft or airplane and helicopters are operated. How do we relate with other countries that want to fly in Europe? What are the infrastructures in terms of ground infrastructure, the aerodromes, like airports or heliports, and in the future we will have vertiports as well. And what is how the air traffic management and all the services that are needed for the navigation of aircraft are certified and maintained. So this is what we are dealing with, just in a nutshell. Of course, we could stay here to speak for long, but just to give you an overview of who we are and what we do in Europe. Now we'll move on to the main topic of our discussion today, that is unmanned aircraft system and urban air mobility. And I will present you some points, some ideas of what are the challenges that we are facing in making sure that these new concepts may be operated, but in a safe manner in Europe. First of all, we have introduced, so when we talk, what are we talking about when we hear quite often this term urban air mobility? So here we are referring to the transportation of passengers and cargo that is performed through new generation technologies, and some of those technologies you have seen before in the presentation, but you can see some pictures here, that are integrated in a multimodal transportation system that can be conducted within or out of urban environments in a safe and secure and sustainable way. So those are basically the objectives or the content of what is urban air mobility as we conceive it today. Then there is an important definition that we need to keep in mind when we talk about all this nice future that has been presented, for instance, in the previous presentation by Antidio. We're referring to unmanned aircraft system, but what do we mean by that? So this is the definition that you will find in the European regulations. So an unmanned aircraft system is an aircraft that is operating or designed to operate autonomously or to be piloted remotely without a pilot on board and the equipment to control it remotely. So first of all, there are two elements in the definition: the aircraft itself that flies and what we call the command unit. The command unit is basically the unit controlling the aircraft. That can be your mobile phone or can be more complex structures that you see here on the screen. There is also another two important elements which are contained in this definition. One is the definition of autonomous operation, and the other one is a definition of remotely piloted operation. For the time being, we as an agency, we are focusing on developing regulations to ensure the safety of operations of aircraft that are remotely piloted. And we are not yet focusing on what is on the regulation that will be needed to grant the safety of operations of autonomous aircraft. Here, I'm not today. I'm not the most expert on this, but you are the experts, and you should know what is the definition, the difference, between automation and autonomy. So when we talk about automation, basically, we are considering a use of a system and some information technologies that still need the input of a human in order to be performed. Whereas when we talk about autonomy, so basically here we mean the ability to perform some tasks in complex environment without the input of a human. So the focus today, for the time being, it's on remotely piloted aircraft, which of course imply certain level of automation, but we are not yet able to regulate on a completely autonomous aircraft because the technologies, the underlying technologies, they are not yet fully developed, and we need to acquire more experience before we are able to regulate and to make sure that operations can be as safe as the ones that we know today. These are just some examples that are complementing more or less the picture that Antidio provided you before. So how unmanned aircraft systems are affecting the aviation system. Today, we have already drones that are operating in several domains for inspections, for carrying of cargo, passengers, for creating network of communication networks in the air, or for surveillance. So it's the amount of concepts that that are on the market is quite vast, and it gives you an idea of the complexity of the different scenario in which we are forced to analyze and to identify all the associated risks and to make sure that the operations can continue to be safe. So that's the reason why we exist, because we need to put in place some regulations that enable certain types of operations to be safe. What are the challenges that we are facing when we need to write new regulations? So first, I think we can identify four different domains. So one is the domain of the safety regulation, the domain of the airspace integration, the domain of the full ecosystem, because the urban air mobility, for instance, is a complex ecosystem where several actors or several stakeholders are involved at different levels. And also, we should not forget the aspects linked to the societal acceptance. We will see in a while what this means. When we're talking about safety regulation, here the challenges are, for instance, in keeping up with the pace of technological innovation. So, of course, we are not in the driving seats of the development, so the agency, we are not in the driving seats, but we are relying on the industry to present us their innovations. And of course, robotics and artificial intelligence, those are some of the elements that we are, with which we are being challenged today. And for instance, how to define the levels of automations, how to embed in the regulation all the notions of autonomy and the types of autonomy that are being developed by the industry, how to deal with the new aviation actors. For instance, until a few years ago, we were used to an industry landscape which with some industries that have been in the business for decades. Just to name some names, like for instance Airbus or Leonardo or British Aerospace, for instance. Those are names that ring you a bell for those that are passionate for aviation. But today we have a lot of new actors that are bringing a lot of innovations, but on the same time they are lacking the experience when it comes to of these big players that we had so far. So that is one challenge that we are dealing with. Another challenge that was mentioned before is about the integration, the airspace integration. So basically, the integration in the space of the manned aviation as we know it today, and the future aviation with a manned aircraft system. Also, the development of all the necessary digital services that are needed to support this integration, the development of new rules of the air, and how also to ensure that people are even accepting these new concepts. And you will see that this is an implication of the societal acceptance. Another element of interest is another challenge that also we are facing is the ecosystem integration. So how we make sure how we can integrate in the current landscape, for instance, a city landscape as we know it today, the future infrastructures that are needed to deploy urban mobility, like the vertiports. So we will need some platforms where these aircraft will have to operate, where, for instance, they can be either small platforms like the ones that you've seen in the previous presentation, or even bigger ones where aircraft that are carrying cargo or passengers will be operating. How can we deal with the preservation of wildlife? How can we ensure that these infrastructures are properly integrated in a multimodal transportation system? So if we want to achieve really the full benefits of the urban air mobility. And last but not least element of complexity is given by the societal acceptance of people. So how much people are willing to accept those new concepts? Would you, for instance, be accepting a drone delivering a pizza in the garden of your neighbor or in front of your house? Would you be, for instance, be willing to accept an emergency medical service performed at night with a VTOL aircraft that is landing on your building because they need to bring a doctor on a crash accident, for instance, scene? What are the risks associated with security and cybersecurity? The risk associated with the privacy and liability. So those are all elements that have to be kept into account when developing a new regulatory environment. On top of this, so these domains, they're not all isolated. There is another layer of complexity due to the fact that all these domains have strong interactions, and on top of this, the regulator. So we are not the only regulator that comes into place when placing rules, but you may think that, for instance, in cities where vertiports will be built, the mayor of the city will have to give some authorizations or will permissions to build some new structures or to allow certain types of operations. So it's a complex environment, it's a complex ecosystem that needs inputs and contributions from several stakeholders. One question one challenge that we were facing at the beginning when we started drafting the regulation was, how do we write new regulations for these new technologies? This picture is giving you a notional idea of how the number of fatalities, because we measure safety through indirectly through the number of fatalities. So less fatalities we have, the safer is a transportation concept. You see over the course of time, so since the jet engine technologies and supersonic transport or the fly-by-wire, the introduction of new avionic suites or composite materials, we have always regulated by imposing certain prescriptive requirements. And one of the safety objectives was that there must be no catastrophic failures before 1 billion flight hours. So that is, so basically, in a given complex system, you need to fly 1 billion flight hours before one catastrophic failure can show on the system. And this is a very prescriptive requirement. And the challenge that we faced was, how can we use the same approach, or we have to rethink a new approach to write rules? That's the reason why we, when you deal with, of course, urban mobility in general, and we shifted a little bit our mindset. So basically, we had to consider all the new technologies. So the digitalization of services, the new type of propulsion system that are powered by lithium batteries, the additive manufacturing, the detect and avoid technologies for navigation purposes. So the use of artificial intelligence, how can we put together all this information and make sure to apply regulation, to develop regulations that are proportionate and different depending on what you do. So that's the reason why we came up with the concept, which is operation-centric, risk-based, and performance-based. What does that mean? It means that, let's assume that we have exactly two equal aircraft, US flying, two drones, completely similar drones. So one drone is performing an operation in the middle of the sea, delivering a small package on an oil refinery, and the same drone delivering a package overflying the city close to a stadium where there is a football game ongoing, and there are people on the street because it's the Black Friday and everybody's going to shop. So you can imagine that, so the way we approached the point was, okay, let's try to impose requirements in terms of safety that are different depending on the nature of the operation that you perform. So what is the risk of your operation? And the riskier is the operation, the more stringent are the requirements that have to be observed. Because at the end, it is there is very little risk if the drone that is delivering a package crashes into the sea when compared to the same drone that is performing the same operation, but for instance, over a stadium that is filled with people. So that's the approach that we have taken. So we developed this sort of new approach in imposing requirements that are not prescriptive a priori, but they are proportionate and based on the type of operation and on the risk of operation that is being performed. Another interesting element, which I think is of interest also for the community that we are talking today, is the use of artificial intelligence in aviation. How to merge basically the safety aspects and the ethical aspects of artificial intelligence. Here also the agency has developed an artificial intelligence roadmap that is available on our website, where we have basically discussed and put forward our ideas. How do we see the process that will enable in the future to use such systems in the aviation domain for different purposes. For instance, before we were looking at the video of the drone recognizing a swarm of birds in the sky. So that can be one application, but the same another application of artificial intelligence in aviation may be the traffic deconfliction with manned aircraft, for instance. So there is a lot. We have envisioned this roadmap, and the elements are in these documents that I'm sharing here with you. So in case you want to take a look, I think it's an interesting reading, so that will give you an idea what's coming up in the future. I was mentioning before the airspace integration, the difficulties of how to integrate the space above us, not only to make sure that the manned aviation and the unmanned aircraft systems will be able to cooperate. And to do so, we have created a new concept, a new set of rules that is called U-Space, but is basically the unmanned aircraft system traffic management system. That is basically, it implies three concepts. It's the volume of airspace above us, it's the set of services that are provided in a given space, and also the type of information that are exchanged between the unmanned aircraft and the manned and unmanned aircraft themselves. So all of these to ensure that all stakeholders can fly safely in the sky. This is a picture that you have seen before also, because this is a real hot topic for us. So how to make sure that we are able to transition from this left side of the slide, where everybody is separated in his own world, and try to integrate all the actors in a consistent and safe manner in the sky. Another important element is also the, when I was referring before to the ecosystem integration, how you make sure that these structures that you see on the screen here can be nicely integrated in the current cities as we know them today. So the only real installation that you see here is this one in the middle of the screen, and this is performed in Singapore by Volocopter. The other, so this one are all 3D reproductions or designs, but they give you an idea how complex, for instance, would be to integrate these vertiports in the cities and to make sure that they can be a node of exchange between the car traffic, for instance, the land traffic and the air traffic. And also these structures are bringing new challenges because, for instance, in these structures, we will have to be able to recharge large amount of batteries. So there are risks associated to the management of batteries. So typically a fire risk. There is a need of providing these infrastructures with a lot of energy because they need a lot of energy to recharge the batteries. These infrastructures need to be safely integrated in the cities. For instance, this is just a study. This is Cologne, where we say, so the agency is close by here. And this is just a simulation how a vertiport close to the train station, this is the train station, could be integrated. And basically, what are the volumes that need to be designed? And basically, these volumes are needed to ensure the safety of the operations because an aircraft manufacturer, so a VTOL aircraft manufacturer, will have to demonstrate that its own aircraft is able to fly safely in a controllable way within these volumes in order to grant the safety of operations. Another aspect that I mentioned before is the societal acceptance aspect. The agency has run a few months ago a study on the societal acceptance by running some surveys with in 6 different European cities, about 4,000 European citizens. And we asked them a lot of questions, what were their ideas and opinions on certain concepts. This study is published on our website. And these are the 10 most important points that came up from this survey. So basically, European citizens believe that these concepts are very good to be seen in the future. So there's an initial positive attitude. There is quite some strong support for use cases that are in the public interest. For instance, the emergency medical services. This was the top scorer, for instance. Also, the delivery of packages. Just to give you some examples, there are of course some expected benefits in terms of faster and cleaner, better connectivity, but also concerns. In terms of concerns on safety, on the environment, on the noise aspects, on the security, the privacy, and of course, there are also the importance of what we were discussing shortly before, how to integrate these infrastructures on the ground to make sure that they properly fit in the cities. So there is a lot to be done. And this is just a slide that is summarizing more or less what are the activities that we as an agency have started and are currently performing in order to make sure that this full ecosystem that I showed you before will be properly deployed in the future. So we are looking, for instance, at how to certify the aircraft, how to maintain them, how to build vertiports, how the operators of aircraft what would be the rules that operators of aircraft will have to observe, how to train the personnel and to train the pilots, looking at the technology developments like detect and avoid technologies, the C2 link, which is the link between the ground control station and the aircraft, the digitalization aspects, so artificial intelligence, autonomy, cybersecurity, all new emerging technologies in different domains for flight controls, in the avionics, in the propulsion system, energy management. The use also of training and simulation, this is also an interesting domain where, because in the future, maybe we will have pilots that will not be trained. So in order to have a remote pilot, you don't need to fly an aircraft, but you need to have certain skills that are different from the skills that the current pilots today have. How we can promote a better coordination between the military people, those are the ones that are using unmanned aircraft systems since long times, much better than the civilian ones, and also how to make sure that we can protect the installations like aerodromes or some sensitive buildings from the malicious use and the uncooperative use of drones. And also to make sure that whatever we do in Europe can be exported worldwide and become the standards also in other countries. So we also cooperate in the research domain. We follow the research that are performed, for instance, in the CESAR campaign, all the projects that are activated under the Horizon 2020 financing scheme, and also the demonstrators. So this is just an overview of all the activities that we are performing, and that basically those are the enablers and on which EASA is working to make sure that urban air mobility can be deployed in a safe manner in the future. Thanks for your attention, and in case you have questions, I'm happy to take them on board.
Okay, Giuseppe, that was magnificent. Thank you very much. I think we've all been absolutely enlightened about so the factors that form part of your deliberations and concerns in your world, and indeed our world in the near future. Okay, we are slightly behind time, and we will shortly introduce our final guest, but there is time for a couple of minutes of questions. So Giuseppe and Antidio, I'd like you to imagine that you are taking the armchair in the imaginary studio to receive questions from anyone within our group who is still with us, who would like to ask questions or make a point to Giuseppe and Antidio on this theme of drones. If you would, then just open your microphone. Is there anyone from EU Robotics? Anyone from Vol Team? Any of our students, our emerging talent from the future who has a question about this? Then you are absolutely welcome to ask a question at this point. Well, could I just, I've got a question. Giuseppe and Antidio, do you know each other? Do you have any kind of professional interaction?
I am not sure, because maybe Antidio is better memory, because we as an agency, we are interacting a lot with of the institutions and research centers and applicants and all entities that are involved actually in this rulemaking exercise. Maybe I think I've heard or seen similar presentation in the past, but I don't know if it was delivered by Antidio. So I don't think that we know each other directly. But I've seen the content of the presentation in the past.
Yes,
at least part of it.
No, I mean, this is a small world yet, and for sure we have probably been in some workshops organized by EASA.
Probably,
or,
yes. Yes.
By Zoom or before the pandemic, in person. But I don't know. We have at least we have not collaborated directly. I know Maria from EASA, and also
yes,
Natale.
She's the program manager.
Natale as well from the interaction with Eurokai, because I was the focus team leader of the Solar Focus team during 3 years, so also I interacted with Natale sometime.
Yeah, but that's the reason why, because I'm more in charge of the regulation for the drones operated in the certified category and manned and VTOL aircraft in general, and whereas Natale is more in charge of the open and specific category. So that's the reason why I've been in charge with him. I've been in contact with him in the previous
experience. That is a pleasure. It's a pleasure.
Yes, pleasure to me as well.
Excellent, and indeed it was a pleasure for all of us to hear you both today. So thank you very much indeed. We need to move on now. That was fascinating, but we have to go to our final theme. Indeed, we are delighted to go to our final theme for this midweek session of the central event for European Robotics Week 2021. ERW wouldn't be the same without a focus on education, which remains an important part of its purpose, both in educating the wider public about robots and indeed in encouraging young people into STEAM, or robotics as subjects for study and as a career. Alberto Bellini is an associate professor of electric machines and drives in the Department of Electrical, Electronic and Information Engineering at the University of Bologna. Alberto is himself a graduate from the University of Bologna, where he also obtained his doctorate in electronic engineering and computer science. As with our other speakers today, I do not have time, unfortunately, to do justice to his full CV and entire list of achievements. What is relevant to our theme this afternoon is that he is a pivotal figure in the Climate-KIC, knowledge innovation community, whose goal is to work to accelerate the transition to a zero carbon, climate resilient society. So supported by the European Institute of Innovation and Technology, EIT, the Climate-KIC identifies and supports innovation that helps society to mitigate and adapt to climate change. And so within the Climate-KIC, Alberto coordinates a project that promotes the circular economy by digital technologies. So here to speak on the theme of EIT, education, innovation on sustainability and industry, please welcome Alberto Bellini.
Hello, thank you for the presentation. Thank you, Steve. I hope you can hear me.
Yes, perfectly.
Yes. Yeah, thanks a lot. So thanks for the introduction. I would like to share with you some ideas and results dealing with education, of course, but also innovation. And specifically, I will try to give you a brief presentation about the initiatives under the umbrella of EIT. So basically my talk will be dealing with this 4 items. First, an idea of EIT, that is a tool that maybe nobody knows that is important for education and innovation in Europe. And second, I will be dealing more in detail with innovation communities behind the umbrella of EIT. And third, as Steve was saying, more specifically on the education and innovation initiative running under this set of communities. And last but not least, some examples of knowledge innovation communities. And of course, I will be happy to have some discussions with you. So starting from EIT, EIT stands for the European Institute of Innovation and Technology. So this is basically an overarching education and innovation system in Europe. So an overarching umbrella over all the academia and research centers in Europe. So it is an independent EU body, meaning that it is behind the European Union, specifically the European Commission, but it is independent. So we will see in a moment, it has a specific budget under the H2020, then Horizon Europe funding structure, but it is totally independent. And as it is written here, the vision is to empower innovation and entrepreneurs. And to do that, of course, there are multiple solutions and multiple paths. And EIT is trying to do innovation through integration. So basically, the fact sheet of EIT can provide us more hints and clear information about its mission and vision. First of all, it was set up in 2008, and it brings together more than 2,900 partners. So far, it is the largest European network for innovation. And it connects actors from the knowledge triangle that you probably already know, but I will detail in a moment for those that not know it before. So basically, currently, there are 8 knowledge and innovation community that is my second bullet. And there are many decentralized structure across Europe, currently 64. And as it was said before, one of the main purpose is entrepreneurship. So they are fostering and supporting startups and scale-ups. Currently, more than 3,800 startups have been supported by EIT. We will see soon after the funding mechanism, but basically the idea is to have a leverage on public money, so to produce private funding. And specifically, so far, about 4 billion euro were raised of external private capital from EIT. And of course, you see numbers for jobs and students that are very important to this audience. As I said before, an important part of the EIT mechanism is the funding model. So basically, they were managing a budget of 2.4 billion euro in the H2020 framework. So the strategy of EIT for 2014 and 2020 was based on a support of the European Union of about 2.4 billion euro. And how it works, this funding, where basically this funding is a competitive funding offered to their partners, so that the new and important information to get is that it is a competitive set of tender, so calls specifically issued by EIT parts, but it's open only to partner. So the idea of community is very important, because the first step is you have to enroll your institution into the community. And of course, the access is closed. So you have to be selected and be assessed by previous member and the board to be eligible for that. So there are competitive tender, but only for members of the community. Second, very important, is that you can receive up to 100% funding of your activity, but you are forced to produce complementary activities. Meaning that if you receive 100 unit of money, this is the 25% of your project, and you have to raise at least a leverage of 4, so 3 times more what you receive. And these complementary activities must be other activities, either public or private funding, related to the activity. So basically, from the perspective of the EU is investing 100 to result in projects that cover 400. So the idea is that this funding is leverage for innovation or entrepreneurship or new activities. And what you see here is, of course, a bell curve that states the level of funding devoted to the single community. So we will see in a moment that EIT has established 8 different communities on specific topic, and each of that receives a funding per year according to the bell curve. So the idea is to look at them as startups. So basically, EIT, through public funding from the EU, is funding the single community, starting low and going up, and then go up again, down again. The idea is that you must set up a startup, an innovative activity that then goes by himself. So you are setting up the group that then is capable of self-sustaining from the economic point of view. So this is important because it's very specific for the EIT and its community. So look under the umbrella of EIT to the innovation community. K stands for knowledge innovation community. So the innovation community of EIT are direct implementation of the knowledge triangle. This is the knowledge triangle. So basically, each vertex is a specific organization. One vertex is businesses, so industry, including SMEs. Second vertex is academia. And third vertex is research organization. So the idea is that in this community, you have this partner working together, which is the real added value of the community. We are used to projects with some different level of TRL, but often they are pretty much reserved to one vertex. The knowledge triangle added value is that it's mandatory for projects under the umbrella of the EIT to have all the partners from the knowledge triangle. And so, of course, these lead to a set of tools, of methods that are here recalled. So basically, very strong passion and engagement to let people work together with very high commitment. In more detail, these are the 8 communities established by EIT, and you see in different years. So you see here that Climate-KIC, InnoEnergy, and Digital were the first to be established together with EIT. And as a general background, all these 8 communities are very focused. So each of them is covering a specific topic. So of course, Climate-KIC is dealing with climate, Digital is dealing with digital transformation, and InnoEnergy is dealing with the energy transition. And then in 2014, other KICs were added, one dealing with health, one dealing with raw material. Then in 2016, another was added with specific focus on food, and latest in 2018, manufacturing and urban mobility were created. Each of them has a simple structure. They are private companies. And basically, they have a set of owners that are main members. then they are open for membership for the others. And as I said before, they have a public funding that follows this bell curve, typically for about 10 to 15 years. So basically, Climate-KIC, InnoEnergy, and Digital are at the end of their public funding, and they are starting as private company, initially supported by the EIT, but now almost ready to go on their own feet. And of course, they have a decentralized organization in Europe. And as I said before, there are currently 64 location centers in Europe where these communities have their premises or other structure beneficial to their activities. And what are the activities in detail? Education and innovation. So they are covering and support initiatives both in education and innovation. But don't forget, they are receiving funding from the EIT, public funding, and they are selecting projects to support according to the 1-4 rule. So don't forget that the funding mechanism is very peculiar. So basically, you can receive 100 to cover 100% of your project cost, but you have to commit to engage yourself and your company towards a leverage of 3 times what you receive. In terms of education, basically, they are supporting any level of education, bachelor, master, and doctorate, provided that you can have excellence in general and specifically in entrepreneurship and innovation. And so basically, these are a set of programs, education program supported in Europe, meaning that they were awarded by a label stating this excellence. And you see the numbers are quite relevant for each of the innovation community, and these are the global number in Europe. And these are the geographical distribution of courses awarded by the EIT label. A specific example is in our institution, we were awarded of an EIT label for a specific Master of Science course that is named ICT for Climate, that is specifically a master program in electronics and telecommunication engineering. I'm using this example just to show the specific feature of the EIT label. What is the added value of achieving an EIT label? Basically, you receive funding for your student, and we received funding for 3 specific initiatives. One is the Journey, a 5-week intensive climate innovation scheme that is basically an opportunity for students to work together in a very, very specific framework, because you have typically 40 students, 40, coming from different countries and from different disciplines. So you have 3 engineers, 3 scientists, 3 economics, 3 law, and so on. And this is very nice because they work with a design thinking approach towards a specific challenge during the 5-week period that is called Journey, because typically it's 2 weeks in a location, 2 weeks in another location, and the last week in the 3rd location. So it can be 2 weeks in Athens, 2 weeks in Munich, and last week in Helsinki. And then the students are offered specific high-level seminars that the Climate-KIC called Spark. And third, they are obliged to have 6 months of international mobility working towards a climate innovation project. And all these activities is funded by EIT through Climate-KIC. And second leg of EIT activities through the community is innovation. So basically they are supporting innovation project, but as I said before, provided that all the vertex of the knowledge triangle are involved. So these are typical examples of innovation programs that are funded by EIT communities. Deep demonstrations, meaning real case activities, real hands-on activity that represent pathway for radical transformation. So you must produce results from innovation, technology, social science, economics in real impact on cities, communities, regions, or value chain of a specific product. Second is, of course, open innovation program for funding. And third is, of course, startups and entrepreneurship. And fourth is the research innovation. But here there is a specific difference with typical research and innovation project. Here, the knowledge triangle is extended to the so-called knowledge helix, meaning that you have to involve in your project not only academia, industry, and research center, that is already quite challenging, but also civil society and government to be able to raise barriers and solutions together with all the actors of our humanity. And last part from my side, some examples, specific examples of KICs. So some idea at a glance. This is Climate-KIC. You can find in this unique resource location more detail. Climate-KIC is focusing on 4 areas: cities, of course, sustainable production systems, so innovation in industry to reduce carbon dioxide and emissions. Third, decision matrix and finance is, of course, of utmost importance to have funding devoted to the transition towards a climate neutral society. And fourth, last but not least, is agriculture. So sustainable land use to accelerate the transition towards sustainable agriculture, in fact, food production. So the achievements are quite huge. Don't forget, this was started in 28, so it's one of the oldest. And so the number of contacts and partners and results is significant. Second example is raw material, established later, 2014. Of course, it deals with raw material, specifically resource assessment, mining, resource efficiency. So the idea of smart manufacturing. Of course, important topic is critical raw material. So how to proper manage the end of life and how to get and save, secure critical raw material. Then, of course, recycling, circular economy. And last, of course, eco-design to promote circularity. These are the innovation hubs of raw material. Each KICs has decentralized office in each geography. And these are the activities made by the Raw Material Academy. Each community has specific education program that, as I said before, in general, are covering all the level of education: master programs, PhD programs, lifelong learning, and wider formal learning. Another example is manufacturing, that probably is quite interesting for this audience. Manufacturing is recent, so was established in 2018, so it's now starting its setup, and its activities are similar to the others. So business, education, innovation, support to regional activities, and cross-KIC, meaning cross-cutting topics. The four flagships are very interesting, I guess, to this audience. So people and robots for sustainable work, additive manufacturing for full flexibility, waste-free manufacturing for a circular economy, and platform for digitized value network. So the four dimensions of innovation in manufacturing, from robots to flexibility to reuse of material for the circular economy to digitization. And of course, these lead to specific outcomes that are the strategic objectives here. Of course, we don't see results here because it's very new, but we see goals. So we have specific goals by 2030 that are to attract private funding and create startups. So I guess this is the most interesting information for you, for your community. This is a tool that can be considered for partnership and to co-design projects together. So that's all from my side, and thank you for this opportunity. I will be happy to answer any question you might have.
Okay, so Alberto, thank you very much indeed for that. You've given us some insights into an area that I certainly didn't know much about at all beforehand anyway. There's clearly a message in there about sustainability, and that's one that we should all hear, certainly. If there are any questions, then those of you who are still with us at this 7 in the evening Central European time, this is your opportunity to ask your question. I'm just looking to see if any microphones are opening because people are about to ask a question. I see no such movement. Okay, last opportunity to everyone. I think people, Alberto, people have been very happy just to listen and to think about the presentations today rather than to take an active part. So therefore, I think that we should bring things to a close. So Alberto, thank you very much indeed for joining us this evening. That does indeed wrap up the central event for today. So it remains for me to thank the students from the robotics competition winning teams, Daphne, Arachne and Vol team, and to their coordinator for the competition, Emanuele Micheli from Scuola di Robotica. Clearly, I'd like to thank Antidio Viguria and Giuseppe Scannapieco for broadening our sense of what's possible, what's probable, and what's coming soon in the world of drones, and not least to Alberto Bellini. Finally, from a personal point of view, I really want to thank Reinhard Lafrenz, Secretary General at EU Robotics, and also Alessandro Micheli and other colleagues in Bologna who together enabled this central event to happen. So thank you for your attention. And just before we close, I pass over to the President of EU Robotics, Bernd Lippert.
Thanks a lot, Steve. And thank you all from my side and on behalf of EU Robotics to all participants who made this great event possible. Yeah, I'm impressed, even knowing the community, by our students. We learned a lot during the last 2 hours. Thank you, Emanuele, Antidio, Giuseppe, and Alberto. And even if not many participated at the moment, I'm sure that the recording of the event will still be watched by many interested people. It was a great event. It's a great week. and continuing the success story of robotics together with your help. Yeah, for today, I would like to say goodbye to everybody and wish us all a nice evening, and please stay safe. Thanks a lot.
Thank you. Good night.
Good night.